Hello and welcome to the series of e-learning modules on time reversal, factor reversal and circular test. At the end of this session, you will be able to understand the tests applied to any formula to indicate whether it is satisfactory or not. The following tests are discussed: time reversal test, factor reversal test, circular test. Understand the method of testing the construction of index numbers using these tests. The choice of a formula for the construction of index number is a two-sided problem. It involves the choice of a method of averaging as well as the choice about the system of weighting. Several formulae have been suggested for constructing index numbers, and the problem is that of selecting the most appropriate one in a given situation. The following tests are suggested for choosing an appropriate index: unit test, time reversal test, factor reversal test, and circular test. Unit test. It requires that the formula should be independent of the units in which or for which prices and quantities are quoted. This test is satisfied by all index number methods except the single unweighted aggregative index method. This test is satisfied by all index number methods except the simple unweighted aggregative index method. Time reversal test. A test that may be used under the axiomatic approach, which requires that if prices and quantities in the two periods being compared are interchanged, the resulting price index is the reciprocal of the original price index. The time reversal test requires that the index for the later period based on the earlier period should be the reciprocal of that for the earlier period based on the later period. In other words, the two should be reciprocals of each other. That is, P01 into P10 is equal to 1. Factor reversal test. The factor reversal test requires that multiplying a price index and a volume index of the same type should be equal to the proportionate change in the current values. Suppose the roles of the prices and quantities in a price index are reversed, it will yield a quantity index of exactly the same functional form as the price index. The factor reversal test used under the axiomatic approach requires that the product of this quantity index and the original price index should be identical with the proportionate change in the value of the aggregate in question, also known as a product test. Symbolically, P01 into Q01 is equal to value index. Circular test. It is concerned with the measurement of price changes over a period of years when it is desirable to shift the base. If P01 represents the price change of the current year on the base year and P12 the price change of the base year on some other base, and P20 the price change of the current year on the first base, then following equation should be satisfied. P01 into P12 into P20 is equal to 1. Now, let us discuss the time reversal test in detail. Professor Irving Fisher has made a careful study of the various proposals of computing index numbers and suggested various tests to be applied to any formula to indicate whether or not it is satisfactory. The two important ones are the time reversal test and the factor reversal test. Time reversal test is a test to determine whether a given method will work both ways in time, forward and backward. In the words of Fisher, the test is that the formula for calculating the index number should be such that it will give the same ratio between one point of comparison and the other, no matter which of the two is taken as the base. In other words, when the data for any 2 years are treated by the same method but with the bases reversed, the two index numbers secured should be reciprocals of each other so that their product is unity. Symbolically, the following relation should be satisfied. P01 into P10 is equal to 1, where P01 is the index for time 1 on 0 as the base and P10 is the index for time 0 on the time 1 as base. If the product is not unity, there is said to be a time bias in the method. For example, let us say that the price of wheat from 2008 to 2009 has increased. The price in 2009 should be 133% of the price in 2008 and the price in 2008 should be 75 of the price in 2009. One figure is a reciprocal of the other. Their product 1.33 into 0.75 is unity. This is obviously true for each individual price relative, and according to the time reversal test, it should be true for the index number. Let us now look at how many of these methods that we have discussed has satisfied the time reversal test. Let us take the Laspeyer's method. In this method, we calculate the index by taking the summation of P1Q0 divided by summation P0 Q0. Name this as equation 1. Now, when we apply the concept of time reversal, P01 is equal to the summation of P1 Q0 divided by summation P0 Q0, which is same as equation 1, and P1 naught is equal to summation of P0 Q1 divided by summation P1 Q1 denoted in equation 2. When taken the product of equation 1 and 2, we should get P01 into P10 is equal to unity. Here, after substituting the equation, we see that P01 into P10 is not equal to unity, and hence this method does not satisfy the test of time reversal. Next, let us take the Paasche's method. In this method, we calculate the index by taking the summation of P1 and Q1 divided by summation P0 Q1 as in equation 1, and P10 is equal to summation of P0 Q0 divided by summation of P1 Q0 as in equation 2. When taken the product of equation 1 and equation 2, we should get P01 into P10 is equal to unity. Here, after substituting, we see that P01 into P10 is not equal to unity, and hence this method does not satisfy the test of time reversal. The next method we will discuss is the Fisher's ideal index number method. In this method, we calculate the index number as price index is equal to square root of summation of product of price of the current year and the quantity of the base year divided by summation of price and quantity of the base year multiplied by the summation of the product of the price and quantity of the current year divided by summation of price of the base year and current year quantity as equation 1. Changing the time P1 naught, the formula will be price index is equal to square root of summation of product of price of the base year and the quantity of the current year divided by summation of price and quantity of the current year multiplied by the summation of the product of the price and quantity of the base year divided by summation of price of the current year and quantity of the base year as equation 2. Now, by taking the product of both the equations, we will get unity as the answer, which indicates that Fisher's ideal index number satisfies the test. Similarly, there are 4 more methods which do satisfy the test. Simple geometric mean of price relative. Aggregates with fixed weights. The weighted geometric mean of price relatives if we use fixed weights. Marshall-Edgeworth method. Thus, a time reversal test used with index numbers that is satisfied when the new index is the reciprocal of the original index if the functions of the base period and given period are interchanged. The advantage of index numbers meeting the criteria of the test is that a symmetric comparison of the two periods is obtained and the results are consistent whether one or the other period is used as a base. Factor reversal test. The factor reversal test is another test of consistency suggested by Fisher. It holds that the product of a price index and the quantity index should be usual to the corresponding value index. In the words of Fisher, just as each formula should permit the interchange of the two times without getting inconsistent results, so it ought to permit interchanging the prices and quantities without giving inconsistent results. That is, the two results multiplied together should give the true value ratio. In other words, the test is that the change in price multiplied by the change in quantity should be equal to the total change in value. The total value of a given commodity in a given year is equal to the product of the quantity and price per unit. The ratio of the total value in one year to the total value in the preceding year, that is P1 Q1 by P0 Q0. For example, let us assume that the price and quantity doubles from one year to the next. That is, the price relative is 200 and the quantity relative is 200. Then, the value index should be 400. The total value in the second year would be 4 times the value in the first year. A symbolical representation can be done. Let us assume that P1 and P0 represent the prices and Q1 and Q0 represent the quantities in the current year and base year respectively. Then P01 represents the change in the price in the current year and Q01 represents the change in the quantity in the current year. Then the product of P01 and Q01 is equal to the value ratio summation of P1 Q1 by summation of P0 Q0. Note, if the product is not equal to the value ratio, then in this test it means there is an error in one or both of the index numbers. The factor reversal test is satisfied only by the Fisher's ideal index number. Fisher's ideal index is equal to the square root of the summation of product of price of the current year and the quantity of the base year divided by summation of price and quantity of the base year multiplied by the summation of the product of the price and quantity of the current year divided by summation of price of the base year and current year quantity when in the equation we change P to Q and Q to P, we will get the quantity index is equal to the square root of the summation of product of quantity of the current year and the product of the base year divided by summation of quantity and price of the base year multiplied by the summation of the product of the quantity and price of the current year divided by summation of quantity of the base year and current year price. By multiplying the two indexes, we will get the result as the value ratio. Let us take an example to understand the calculation for time reversal test and factor reversal test. Calculate Fisher's ideal index number from the following data and prove that it satisfies both time reversal and factor reversal test. Solution. First, let us prepare the table for calculating the various values needed for the solution. In the first column, we have the commodities. The second column, we have the base year price P0. In the third column, we have the base year quantity Q0. In the fourth and the fifth column, we have the price P1 and quantity Q1 of the current year. The sixth column indicates the product of P1 Q0 and the total is equal to 5,108. The seventh column indicates the values of P0 Q0 and the total is equal to 2,464. The eighth column gives the product of P1 Q1. The total is equal to 6,532 and the last column gives the value of P0 Q1 and is equal to 2,710. Substituting the values in the formulae for finding the index, we will get square root of 5,108 by 2,464 into 6,532 by 2,710 into 100, which is equal to square root of 2.073 into 2.410 into 100 is equal to square root of 4.995 into 100 is equal to 2.235 into 100 is equal to 223.5 as the index number. Now, we will test the consistency by using the time reversal test and the factor reversal test. By substituting the values in the product of P01 and P10 we will get as the square root of 5108 divided by 2464 into 6532 divided by 2710 into 2710 by 6532 into 2464 divided by 5108, which is equal to square root of 1 is equal to 1. Hence, time reversal test is satisfied. Next, we will substitute the values to check the factor reversal test, where we will take the product of P01 and Q01. We will get it as the square root of 5108 divided by 2464 into 6532 divided by 2710 into 2710 divided by 2464 into 6532 divided by 5108, which is equal to the ratio 6532 by 2464, that is the value ratio. Hence, the above data has satisfied the factor reversal test. Circular test. Another test of the adequacy of the index number formula is the circular test. If, in the use of index number, interest attaches not merely to a comparison of two periods, but to the measurement of changes over a period of years, it is frequently desirable to shift the base. A test of this shiftability of base is called the circular test. This test is just an extension of the time reversal test. The test requires that if an index is constructed for the year A on the base year B and for the year B on the base year C, we ought to get the same result as if we calculated directly an index for A on the base year C without going through B as an intermediary. Symbolically, if there are three indices P01, P12 and P20, then the circular test will be satisfied if the product of all the three indices is equal to unity. The Laspeyer's index. First, let us take the Laspeyer's method. In this method, we calculate the index by taking the summation of P1 Q0 divided by summation P0 Q0. Now, when we apply the concept of circular test considering 3 years 0, 1 and 2, P01 is equal to the summation of P1 Q0 divided by summation P0 Q0. P12 is equal to summation of P2 Q1 divided by summation P1 Q1. P20 is equal to summation of P0 Q2 by P2 Q2. When taken the product of the 3 years, it is not equal to 1. And hence, this method does not satisfy the circular test. Similarly, it can be shown that in Paasche's index and Fisher's index do not satisfy the test as the product is not equal to 1. However, the simple aggregative method and the fixed weighted aggregative method satisfy the test can be seen from the following. When the test is applied to the simple aggregative method, we will get summation P1 by summation P0 into summation P2 by summation P1 into summation P0 by summation P2 is equal to 1. Similarly, when applied to the fixed weight aggregative method, we will get summation P1Q by summation P0Q into summation P2Q by summation P1Q into summation P0Q by summation P2Q is equal to 1. The advantage of this test is that it reduces the computation every time a change in the base year has to be made. Index numbers can be adjusted from year to year without referring each time to the original base. The disadvantage is that weights in the index numbers depend on the periods between which comparisons are being made. If these periods change, the weights change. Here's a summary of our learning in this session. We have understood the method of testing and constructing index numbers using time reversal test, factor reversal test, and circular test.